And today we'll learn chapter 8. This chapter that's character of digits. So this chapter, the knowledge point, it's very little. I only show you how to represent a number based on their base. So usually we just research the number based on 10. Okay, base is 10. But for other base, that's similar. Okay, so especially in AMC 10 test, a lot of this kind of problem. It's also very interesting and also very hard. Okay, now let's see first how we represent a number. Suppose we have a number m, that's 2,345. We can represent this number as 2 times 10 power 3, right? Plus 3 times 10 power 2, plus 4 times 10 power 1, then plus 5 times 10 power 0. So actually this one you can write like 2,000 plus 300 plus 40 plus 5, right? You can also write this number as 234 times 10, then plus 5. You can also write this number as 23 times 100, then plus 45. You can also write this number as 1,000 times 2, then plus 345. For the general case, we can write this number as, suppose their digits, it's an minus 1, blah, blah, to a1, a0. You can write this number as 10 powers n times an plus 10 power n minus 1 times n minus 1. Then plus blah, blah, to 10 power 1 times a1 plus 10 power 0 times a0. Okay, so this is one way you represent this number, use base 10. Another way, you can use the first digit to the second last digit, an to a1, then times 10, then plus a0. You can write this way, right? You can also use an to a2, then times 100, then plus a1, a0. You can also do the 1,000 times an minus 1 to a3, then plus a2, a1, a0. For general case, you can also use any number 10 power k, then times an minus 1 to ak, then plus ak minus 1, ak minus 2 to a1, a0. Okay? See, example is like this. This is a very simple, okay? But the problem is really hard. Okay, now let's try an example. Let's say this. Set Sn and Pn denote the sum and the product, respectively, of the digits of the integer n. For example, P23 equals 6 because the product of 2, 3, that's equals 6. S23, that's sum of 2 plus 3, that's 5. This equals 5. Suppose a number n is a 2-digit number such that n equals 3 times Pn plus Sn. How many values of n are there? I'll give everybody 2 minutes. Try this. So which one is your answer? Then let's say, Emily, prepare, share your solution. See here, first you need to understand what is Sn, what is Pn. Here they give you example. Suppose you have number 23. P23, that means the digit 2 times 3, you get 6. S23, that means the sum of these two digits, 2 and 3, then you get a 5. Now here, suppose they give you a 2-digit number, okay? 2-digit number. You can set this 2-digit number equals 10A plus B, right? Because we suppose this 2-digit number is AB. A, that's in the, it's a digit on the 10th digit. B, that's a digit on the 1st digit. Now this number is AB. If we represent this number as what we show on the previous page, this should be 10A plus B, right? Now they give you this relationship, this equation, n equals 3pn plus sn. So Pn, you need to use AB to represent Pn. What is Pn here? This one should equals the product of these two digits. So that's equals A times B. And what is Sn? Sn, that's a sum of these two digits. That's A plus B. Okay? So based on this equation, we get this. We can rewrite this one will be 10A plus B equals 3 times Pn. So that's 3AB plus Sn. That's A plus B. We got this equation, right? Now think how to simplify this equation. Simplify, say both sides you have B cancel out. Then both sides minus A. You got 9A equals 3 times A times B, right? So then say both sides divided by 3. Then got 3 times A equals A times B, right? Now, can we cancel out A? Emily, can you tell me, can we cancel out A?
Yeah.
Why? Yes, we can cancel out A. Why? Because we suppose the 10th digit, that's A. If A equals 0, you know, when A equals 0, we cannot cancel out A, right? If A is not 0, definitely we can cancel out A. Because the A is 10th digit of this number n. If A equals 0, this number is not a 2-digit number. That would become a 1-digit number, right? Suppose A equals 0, like 0, 6. This actually represents a 1-digit number. It's not a 2-digit number. If n is a 2-digit number, that means 10 digits should not be 0. So that means A is not 0. It's not 0, we can cancel out A. So we got B equals 3. So that means if this equation satisfied, the 1st digit of this number should be 3. Okay? So then what's your answer? How many this kind of numbers there? How many values of n are there? You only have limitation for 1st digit. This B should be 3. The choice for A, how many choice for A, Emily?
9.
9 choice. What are these 9 choices?
1 to 9.
Yes, 1 to 9. So we got the answer should be E, because these numbers 1, that's 13, 23, 33, 43, 53, 63, 73, 83, and 93. This is the 9 numbers satisfy this requirement for this equation. So then we got 9 choices for n. So this is the answer for this problem. Okay. So now let's go to next example. Suppose second example. This one, the product of two-digit number and 5 is equals to the product of the same two-digit number with its digit reversed and 6. What is the sum of the digit of the digit of the number? Okay, give everybody 2 minutes. See, this number is still a two-digit number. Product of this two-digit number with 5 equals the product of the same two-digit number with a digit reversed and 6. What is the sum of the digit of the number? Okay, you can still do the same way. Suppose this number is, because that's two digit, suppose that's AB, then we can write this one equals 10A plus B, right? So the product of two-digit number with this number with 5 equals 6 product with reverse of this number. That will be 10B plus A, right? So then we got this equation. Now let's think how we can simplify this equation. So distribute this 5. We got a 50A plus 5B equals 60B plus 6A. So then say both sides minus 6A, we got a 44A. Then both sides minus 60, we can, let's see, we can both sides minus 5B, we can get the 55B. So then we cancel out common factor 11, we got a 4A equals 5B. Okay. Now let's see. This number satisfies this requirement. The 10th digit times 4 equals 1st digit times 5. Okay. So then let's say we can suppose you can, if you choose 1st digit, you know, if you can choose like B equals 5, B equals 4, then A will equals 5, right? Then that's, you know, 4 and 5 are relative prime. So that's the only choice for this number, right? Do you have the other choices? Kevin, Kevin, can you tell me if this number satisfies 4A equals 5B? A, that's 10th digit. B, that's 1st digit. You know, one choice, we can choose A equals 5, B equals 4. Do we have other choices? Can you tell me? Can you tell me, do we have other choices?
I don't know.
No other choices. See,
Okay.
you know, 10th digits have to be A, 1st digit is B, and also 4 times A equals 5 times B. See, this A and B are all integers, right? A, that's for A, that's 1 to 9, because this is a two-digit number. A cannot be 0. For B, that's from 0 to 9. This have 10 choices, right? But you need to satisfy this requirement. Now, say A can only be 5 and B can only be 4. No other choices. So that means sum of these two number digits, that's equals 9. So the correct answer is E. Okay? Okay, now let's see number 3. Ethan, can you help me read this number 3?
Let club
Can you
X
read number 3? Example 3.
Yeah, let club X denote the sum of the digits of the positive integer X. For example, club 7 is 7 and club 1, 2, 3, 4 is 1 plus 2 plus 3 plus 4 equals 10. So how many two-digit values is of X is club X6?
Okay, see here they use this sign to represent the sum of the digits of positive integer X. Okay, it's similar like SX, right? So that's sum of digits of positive integer X. For example, this one, because you only have one digit, 7, so sum of this digit equals 7. But this one, you have 4 digits. Then you add 1, 2, 3, 4 together, you get 10. So this one equals 10. Then they ask you how many 2-digit value of X satisfy this requirement. Okay, now let's see if this X is a 2-digit number. It's similar like 10A plus B, this kind of form. If X is a 2-digit number, then you know the X, suppose this Y equals this sign. Suppose I use this. It's hard to draw this. Suppose this one. This one, think this is a 2-digit, right? This number, you know, the largest 2-digit number, that's 99, right? So the sum of this one should be less than 18. Less or equals 18, right? If X is a 2-digit number, then this sign should be less or equals 18, right? Because each digit of this X should be less or equals 9. Now let's see this one. First, this one, you know, suppose this one equals, now we need to go from here. Suppose this Y now equals 6, okay? This one now equals 6. Then what is this Y? What is the choice for this Y? You know, X is this a 2-digit number, right? Y it's a sum of this 2-digit number is this. We already know this Y definitely less or equals 18. Then say, you know, we use Y to replace this sign X. Then this one should be based on this equation equals 6. Now my question is, what should be this Y? What is the choice for this Y? You know, one choice, this y equals 6. If this y equals 6, then the sum of 6 definitely equals 6, right? Then another choice, this y can be 15, right? See, this y is less or equals 18. This is only two choices. You have no other choices for y. You know, because this y, it's a sum of these two-digit number should be less or equals 18. So then when y equals 6, y is the sum of a two-digit number, right? So if y equals 6, what is this x? You know, y equals this. If this one equals 6, what is x? So x will have, say, 15. That's a choice, right? And 24. So because 1 plus 5 give you the sum, that's 6, right? So 15, 51, right? 24, 42, and 33, right? So now we have how many? If y equals 6, then we got these 5 numbers, right? Now let's say if y equals 15, what is the number of x? If y equals 15, you know, y that's sum of the digit of x. So then we can get 87. X can be 87. 8 plus 7, that's 15. Then 78, that's 15, right? Then 69 and 96. Now, what else? And you know, 87, 78, 69, 96. Oh, this one we miss one number, 60, right? 60, the sum of 60 also equals 6. Then here, if y equals 6, we get these 6 numbers. Then for y equals 15, we got these 4 numbers. So totally we got 10 numbers. So the answer is C, right? So say this kind of problem looks, you know, knowledge we are using is very basic, but the problem is really hard. Okay, say here y equals 5 or y equals 15. When y equals 6, we got 6 values: 60, 51, 15, 42, 24, and 33. When y equals 15, we got 4 numbers: 96, 69, 87, and 78. So totally we have 10 values. Okay, so now let's see example 4. This one, let's see. Jason, can you help me read this problem?
Okay. Find the smallest 3-digit number that is a multiple of 4 and whose digit sum is 22.
I'll give everybody 2 minutes. Think about this problem. Here is a 3-digit number. And this 3-digit number, it's a multiple of 4. First, you need to notice this is the 3-digit, and also ask you to find the smallest 3-digit number. That's multiple of 4, and whose digit is 22. So now let me ask Jason your question. If a number divisible by 4 what is the character of this number? You know, when a number divisible by 3, the sum of their digit should be divisible by 3, right? So then if a number divisible by 4, what is the character of this number?
The last 2 digits are divisible by 4.
Exactly. Yes, this is a very important character. You need to use this. Say, suppose this 3-digit number is A, B, C. So that means we can write this number it's 100 times A plus 10 times B, then plus C, right? So then they said this number is a multiple of 4. So that means 10A, 10B plus C divisible by 4. 10A plus 10B plus C divisible by 4, you know, that means 10B plus C should be a even number, right? And also say the sum of these 3 digits, that's 22. So that means A plus B plus C equals 22, okay? So then let's say this number 10B plus C divisible by 4, so that means C is an even number. C is even, right? Now, the sum of their digits, that's 22. So let's think. When C is an even number, so that choice can be 0, 2, 4, and 8. Only these 4 choices, right? Now, it's then, and also say the sum of these 3 digits equals 22. Then let's see, all these digits, you know, the digit cannot less than 6. Otherwise, say if one number, suppose C is less than 6, suppose that's 5. Suppose C definitely C is even, right? Suppose C can choose 4. Then say A plus B will equals 18, right? So that means A and B, the only one choice, that would be A and B equals 9, right? So then that number will be like 994, right? 994, say you check last 2 digits, 94 is not divisible by 4, right? So then let's say, you know, here they said all the number ABC should not less than 6. Otherwise, say the sum, like say if C equals 4, A plus B should be equals 18. Then that's only one choice, A and B equals 9. But then you got that number 994 is not satisfy the requirement. So then now let's see, if C equals 8, you know, C cannot be less than 6. 4, that's too small. So the only choice for C, that's 8. When C equals 8, that means A plus B will equals 14, right? A plus B equals 14. What number we can get here? You know, you still need a last 2-digit number should be divisible by 4. If C equals 8, the number what we can get, that would be, say, A can be 6, then B will be 8, then C, that's 8. This is one choice. Another choice we can get that, say, this is a 9, this is a 5, and then this is 8. This is another choice, right? You can also get, let's, if this one equals 14, let's see, what is the other choice you can get? That's only these two choices, right? Now you check if this last two-digit number divisible by 4. So 58 is not divisible by 4, right? And 88 divisible by 4, right? So this one, it works. Now let's see if we have other choices. 700, first A choice, 796. If we add these three digits together, 15 plus 7, that's 22. The last digit, oh, we have another choice, that's 6. 0, 2, 4, 6, and 8. So C can also be 6. If C equals 6, then we got A plus B will equals 16, right? 16, then we have two choices. That's 7, 9, 6. This is a one number. Another will be 9, 7, 6. Definitely this one is not divisible. Last two digits not divisible by 4. This one is divisible by 4. This one also works. But now see, they ask you the smallest. So compare with 688, 796 is too big. So that means correct answer is B, right? So then say this problem first, you know this, the number is multiple, it's 4, then we get C should be an even number. Then that means C has these 5 choices, 0, 2, 4, 6, and 8. Then the sum of these 3 digits, 22. So that means the C only have 2 choices, 6 and 8. 2 is too, C equals 4, 4 is too small. Only 2 choices, 6 and 8. When C equals 8, we got a number 688. When C equals 6, we got a number that's 796. These two numbers satisfy our requirement, but they ask you the smallest, 688, that's smaller. So that's the correct answer. Now let's go to example 5. Leo, can you help me read this 5? Leo. Okay, looks Leo is not here. Okay, now let's see number 5. So suppose that AB and CD are 2-digit positive integers, okay? And AB times CD equals 2016. They ask you to find the greatest possible sum of the 4 digits. Okay, I'll give everybody 2 minutes. Think about this problem. They give you two-digit number. One is AB, another is CD. Then the product, these two positive integer equals 2016. Then they ask you to find the greatest possible sum of the 4 digits. Okay, this problem actually is not hard. So definitely this one, you need to factor in 2016. 2016, let's factor in this number first. Factor this is called a factor tree. So this is an even number, definitely divisible by 2 first. You got a 1008. This is still even number, divisible by 2, 504. Then continue divisible by 2, 252. Then keep divided by 2, 126. Then divided by 2, 63. Then divided by 3, 21. Then 3, 7. So then we can write this number 1, 2, 3, 4, 5. That's 2 power 5 times 3. You have 2, 3 times 3 power 2, then times 7 power 1. This is a prime factorization of 2016. Now you need to write this 2016 as the product of two digits number. Now let's think what we can write next here. So we can combine like 3 times 7 together. So that's 21. So 21 times, 2 power 5, that's 32. 32 times 3, that's 96, right? 32 times 3, that's 96. So 2016 equals this, right? This is one choice. Now let's think. How about we use 32? Use 32. 9 times 6. 9 times 7, that's 63. This is another choice. Then let's say 9, if we use, let's say, 4 times 7, that's 28, right? 28, so here, that would be 8 times 9. 8 times 9, that's 72. Right? Then what else? We can also give 28 times another 2. That would be 56 times 36. This is another choice, right? We can also give 28 times 3. So get 84 times 24, right? So what else? Let's see. I think all numbers probably is already here. Now you check which one give you the largest sum. Say they ask you find the greatest possible sum of the 4 digits, right? So sum of these 4 digits, now let's see. If this one, you add this 4 digit, what do you get? That would be 18, right? This one will be 8 plus 9, that would be 17. This one will be 15 plus 4, that would be 19. How about this? 12 plus 8, right? This one will be 20, right? 12 plus 8, 20. So I think the answer should be A, right? So how about this? This one is 12 plus 6, that's 18, right? So this is the exact way you need to do this problem. Yeah, correct answer is A. Say, first you need to factor in this number. Then try to write these numbers as 2 products of two two-digit numbers. Then check which one gives you the largest sum. Okay. Now let's see this number. Let's say number 6. This number, this example, say how many distinct 5-digit numbers are divisible by 3 and have 14 as their last 2 digits. they ask you how many distinct, that means different. This means different, okay? 5-digit numbers are divisible by 3 and have 14 as the last 2-digit. So we can suppose this 5-digit number is this, ABC 14, right? This is a 5-digit number. Last 2 digits, that's 14. And also think this number divisible by 3. Okay, so you know the sum of digits of this number also should be divisible by 3, right? Because they tell you this number divisible by 3. Then let's see. 1 plus 4, when you divide, that's 5. 5 divided by 3, the remainder is 2. So that means if you add A plus B plus C, this one, when you divide it by 3, the remainder should be equals what? The remainder should be equals 3. This one's mode 3. Right? See, because the sum of these 5 digits should be divisible by 3, right? Because they tell you this number divisible by 3. But the sum of last 2 digits is 5. When 5 divided by 3, the remainder is 2. That means the sum of ABC divided by 3 should give us a remainder 1. Then these 5 digits should be divisible by 3, right? Now let's think how many numbers when we divide by 3 give us remainder 1. Okay, let's think. What is this number? So this kind of numbers, you know, 3-digit number, ABC, you know, add this 3 digit together, you get the remainder is 1. You know, when a number divided by 3, the remainder only have 3 choices. 1 divisible by 3. That means the remainder is 0. Another choice, that's remainder is 2, right? So that means of these 3 numbers, we can get these 3 numbers should be totally we'll have 900, right? Say, you know, they ask you how many distinct, different 5-digit numbers divisible by. So this one here, that's leave the 900 numbers. Totally, we have 900 numbers here. Say, a number divisible by 3, if and only if the sum of these digits divisible by 3. So the 5-digit number XYZ 14 is divisible by 3 if and only if the 3-digit number XYZ leave a remainder of 1 when divided by 3. So there are 900 3-digit numbers. Totally, we have 900 3-digit numbers, of which that's 900 divided by 3 will leave a remainder of 1 when divided by 3. So why we have 900 3-digit numbers? three-digit numbers, say three-digit numbers A, B, C. You know, here that word is very, very, very important. Distinct. Otherwise, it's not 900. Say 900, you know, because the first digit should not be 0. So you have 9 choices for A. Then you have 10 choices for B. You have 10 choices for C. Because B and C can be any number from 0 to 9. So that means for A, B, C, totally you have 900 choices. So that's 900 three digits number here. But only, you know, the remainder equals 1. Only it's 1/3 of that, right? Because when a number divided by 3, the remainder should be 3 choices, either 0 or 1 or 2. Now here we require the remainder is 1. So then the total number of 3 digits number give us the remainder 1 should only 300, right? So that means 300 will leave a remainder of 1. We divide by 3. Okay, so that's the correct answer is 300. So here, this distinct makes the answer is 300. If I take this one away, I allow the digit can be same, then this answer, what should be this answer? Think, if the number can be equal. Now, let's see. Say if the number can be equal, then this one will be, let's say, South A still have 9 choices. Let's say B. This one will be, if A has a 9, how many distinct 5-digit numbers? This one still the 10 choices. This one 10 choices. But say, you can think this later, okay? I just ask you this question. You can think this later. Now let's go to the next one. Okay. This is example 6. Now let's go to example 7. This one, it's 2009 AMC 10A problem. This problem is, what is the sum of the digits of the square of 111, 111, 111? They ask you this. What is the sum of the digits of the square of this number? So that means they ask you calculate 111, 111, 111 times 111, 111, 111. After you times together the number what you get, then add the digits together. Okay. I'll give everybody 2 minutes. Can you do this? So the official solution is just do this multiplication. But when you do do this multiplication, you need to find the pattern. Say, first use 1 times this number, you got a 1, 1, 1, then 1, 1, 1, then 1, 1, 1. Next time, you just shift this number to the left 1 step. You got this 1. No, let me write this 1. It will be like this. 1, then 1, 1, 1, 1, 1, 1. It's like this. Now, next time, you shift 1 more time. 1, 1, 1, 1, 1, 1, 1, 1, 1. Right? Now, you say you have 9 ones here. So then that means you need to write 9 rows. This I already write 3 rows. This first row, second row, third row. Then you keep right. Then later you have 9 rows. Then you add these numbers together. The 1st digit will be 1. Then 10th digit will be 2. Then will be 3. Then will be 4. There will be 5. There will be 6. There will be 7. There will be 8. That will be 9. That will be 8. I think it will be 8 again. 7. There will be 6, 5, 4, 3, 2, and 1. Right? Something like this. If you do it carefully. Then now let's see if we add this digit together. What do we get? You can combine. Let's say combine 1 and 9 together. You got the 10, right? You combine 2 and 8 together. You got another 10. 3 and 7 together, and another 10. 4 and 6 together, you got another 10. So this side, you got a 40, say 45. Now this side, you do 2 and 8 together, 7 and 3 together, 6 and 4 together. That will be 30, right? 30, then you have 36. So 45 plus 36, you get 81. So the correct answer is 81. You can do this way, but do it carefully, that's okay. Then actually there's another way to solve this problem. This way is a little bit, you need a little bit of skill. You can write this number as this: 1, 1, 1, 1, 1, 1, 1, 1, 1. We try to calculate this square, right? So we can write this number as 1, 1, 1, 1, 1, 1, and 1, 1, 0 times 10. Then, no, let's say plus 1. Is this one correct? Yes. Then this one square, right? Now you expand this one. You write this one that equals 1, 1, 1, 1, 1, 1. No, this one we should have not this 0. And 11 times 10, this one square, then plus 2 times, you use that formula. So that's a plus b. This one square equals a square plus 2 times ab, then plus b squared. Use this formula. You got 2 times 1, 1, 1, 1, 1, 1, then 1, 1, then times 10, then plus 1, right? Now let's see this last 2 terms. What is the sum of their digits they give you? Say each one. Say 2 times each one, you got 2, 2, 2. Say 2, 2, 2, then 2, 2, 2, then 2, 2. Then last digit, that will be 1. This one add 0, then plus 1. Say the digit, sum of digits, that will be 2 times how many 2's? 8 2's, then plus 1, right? This is a digits for the last two terms. Then we need to continue calculate what is the sum of the digits from this first term. For this one, we can continue to do this. You know, we can write this one is 1, 1, 1, 1, 1, 1, 1, 1. This square then times 100. 100, this one, we will add 2 zeros to this number. We will not change their non-zero digits. If you calculate the sum of their digits, they did not change, make any change. So you just need to calculate this. For this one, we do the same thing. We can write this one, 1, 1, 1, 1, 1, 1, and 1, then times 10, then plus 1. So this one, we calculate this one square. This one square, we do the same thing. We got this one, 1, 1, 1, 1, 1, 1, then 1, this one square times 10 square, then plus 2 times 2 times 1, 1, 1, 1, 1, 1, and 1. Then times 10, then plus 1. So then this time, say, we have these 2 times together, that would be 2, 2, 2, 2, 2, 2, and 2, 0, then plus 1. Let's calculate the sum of their digits. Then this time we have 7 2's. So that's 2 times 7 plus 1, right? So then we found the pattern. They keep doing this. There will be, the digit will be 2 times 8 plus 1. This is the first term. Second one, 2 times 7 plus 1. Then you keep doing this. The last one definitely will be 2 times 0 plus 1. Then you calculate this. See, to calculate this, then we can take the common factor 2 out. You got that there will be 8 plus 7 plus 6 plus blah, blah, blah plus 1. This is the one, you know, we take away this parenthesis, then that will be 1 plus 1, 1 plus 1. How many ones? We will have from 0 to 8, that's 9 ones. So then we calculate this. 1 to 8, so 1 plus 8 divided by 2, then times 8. So this one will give 4 times 9, that's 36. 36 times 2, that's 72. 72 plus 9, we got 81, right? So we got 81, correct answer, that's 81. You can also do this way. This way require a little bit skill, okay? But if you familiar that this way, it's also very good. You know, if you don't familiar this way, you can still do this multiplication, then find that pattern, okay? This is example 7. Now let's see example 8. This one say a palindrome such as 12,321, it's a number that remains same when its digits are reversed. The numbers x and x plus 72 are 3-digit and 4-digit palindromes respectively. What is the sum of the digit of x? So here they give you 2 numbers. One number is x, another number is 72. And x is a 3-digit number. And x plus 72, it's a 4-digit number. Okay, this is the x, that's a 3-digit number. X plus 72, it's a 4-digit number. And all these 2 numbers are palindromes. Palindromes. Then they ask you what is the sum of the digit of x. So now let's think. The largest 3-digit number, definitely this x should be less than 1,000, right? Should be greater than you know, 3 digits. Now that will be greater than 99, right? Now let's say x plus 72. X plus 72 will less than 1000 plus 72. That will be 1072 less than this number, right? But will greater or equals 1000. But then say x plus 72 is a palindrome. Definitely they cannot be 1000 because 1000 is not a palindrome. So that should be greater than 1000. Now let's think. This number, a number is a palindrome and less than 1072, and also has to be a 4-digit number. So that means this number should be 1001, right? So that's 4-digit and also has to be a palindrome. Say a palindrome less than 1072, and the first digit and the second digit has to be 1 and 0. So that means this 4-digit number has to be 1001. So that means x plus 72 has to be 1001. So then 1001 minus 72. So we get this number will be 9. 9 minus 7, that will be 2. 929. So then you add the digit of this number, that will be, say, 18 plus 2, that will be 20. Correct answer, that's A, right? So time is up. We can stop here. Your access problem, your homework, that will be from page 51 to page 54. The problem that's from problem 1 to 23, okay? The page that's 51 to 54. We can stop here. Everybody, bye.